We've already studied in our A levels that the area of a circle is, for complete circle is pi r square, of half a circle is pi r square by 2. Semicircle area is pi r square by 2, which is exactly half of a circle. Semicircle is half circle. Now the circumference of a circle is 2 pi r, right? And circumference of a semicircle is, you can guess, 2 pi r divided by 2. Pi r divided by 2, which will give us only pi r. We know that the area of a circle is pi r square. Area of a semicircle is pi r square divided by 2. Area of quarter circle is pi r square divided by 4, where r is the radius of the circle and pi is either 22/7 or 3.142. And we also know that the circumference of a circle is 2 pi r. Circumference is the length covered by one complete revolution, right? So circumference of a circle is 2 pi r, of a semicircle is pi r, and a quarter circle is pi r by 2. Now what if I have divided this circle, let's say, into this segment and this segment from the center of the circle. Now this segment, the larger one, is called the major segment. This one is called the major segment, the larger one, and the smaller one is called the minor segment. So this right here is our minor segment. Now in your O-levels, in your Cambridge O-levels, you must have come across this formula for finding the area of the minor segment, which is, let's say, area of minor segment is theta over 360 degrees into pi r square. And this formula is applicable only when this theta, this angle is in degrees. So I have taken the angle which was inside the minor segment. If I put the values of the angle in this formula and the radius of the circle in this formula and use pi, I'll get the area of this segment only, right? Only of this segment. Now, what if I want to find the area of the major segment? So what I'll do is I'll find this theta, right? This angle, which will be 360 minus theta. Now this is the theta right here. So 360 minus theta will give us this angle. Now to find the area of the major segment, I'll use the same formula, but here I'll put 360 minus theta, the angle which is making up the major segment, right? Now if I want to find the circumference of minor segment, right, I'll use this formula, theta over 360 into 2 pi r. So this will basically give me this arc length, right? This arc length is this portion of the circumference of the entire circle. This formula will give me this arc length, theta over 360 into 2 pi r. Now if I want to find the arc length of the major segment or the circumference of the major segment, this one I'll be using this angle 360 minus theta. In the place of theta, I'll use 360 minus theta divided by 360 and multiplied by 2 of pi r. I'll get the circumference of the major segment, or it is also called the arc length of the major segment, right? Now these two are applicable only when the theta is in degrees. Now what if theta is given in radians? What will do then? We already know that 1 radian will give us arc length which is equal in radius to the circle, right? If the angle is 1 radian right here, the arc length, this or circumference of this segment in which the 1 radian angle is present, the arc length of that segment will be equal to the radius of the circle, right? So the greater the radian, The greater the value of the radian, the greater will be our arc length, right? So we'll come up with the formula, which is arc length equals to radius of the circle times angle in radian. Because if this is 1, I'll get arc length equals to r only, which is the radius of the circle. And this, if this is not 1, this will multiply by the radius of the circle and we'll get the arc length respectively. So this is applicable only when the angle is in radians, right? If you have angle in degrees, you can convert it into radian and use this formula for finding the arc length. If the angle is in radian and you wish to find the arc length by using the angle in degrees, you can convert the angle which is in radian into degrees and then use this formula, right, for finding the arc length of that respective segment, right? Now to find the area of the segment, now this arc length is the minor arc length. For the major arc length, for the arc length of the major sector, we'll use r times into 2 pi subtracted from theta, right? This will give us this angle, and this will be only used when theta is in radians, right? So now if I want to find the area of the minor segment, if the angle is in radians, area of minor segment or sector will give this formula, half times r squared theta, the angle of the minor segment, into half into r squared. Now if we want to find the area of the major segment, I'll use half times, you can guess it, r squared 2 pi subtracted by theta, right? So this angle of the major segment will be used in finding the area of the major segment, which holds true for this case and this case. And this is for angle when the angle is in degrees, and this thing is for when the angle is in radians. So moving on, we now have two formulas: arc length, two formulas for degree, the angle is in degree, and two formulas for when the angle is in radians. For arc length, when the angle is in degrees, we'll use theta over 360 into 2 pi r. The area when the angle is in degrees, or segment area, when I do that, segment area is the angle of that segment over 360 into pi r squared. For radians, we have arc length r times theta, r into the angle of the segment, whatever it may be, multiplied by the radius of the circle, and segment area is half r squared times theta, the angle of that segment, right? Now moving on, let's do this example to further clear doubts about it. Let's say I have the circle. The radius of the circle is 3 cm and the angle is in radian, which is 1.025. They have asked me to find the perimeter and area of the minor sector and the major sector. So perimeter is the sum of all sides. Now doing part A, we need to find the perimeter first of the minor sector. Perimeter will be this plus this added into this arc length, because this is our minor segment, the smaller one, this is our major segment, right? Now theta must be at the center of the circle. If it is anywhere inside the circle but is not at the center of the circle, we cannot use the formula that I have just explained you. Theta must be, the angle must be from the center of the circle, right? The segment must be from the center of the circle, okay? So now finding the perimeter of the minor sector, we'll get r plus r plus its arc length. Let's note this arc length by r dash. Alright, so this is 3 plus r theta, and r is 3 into the theta is 1.025 radians. Our answer is 9.075 centimeters. Okay. Now the area will be half r square theta, right? So 1 by 2 into r e squared into 1.025. This gives us 4.6125 squared centimeters. Alright. Now moving on to part B, we need to find the perimeter of the major sector. This is our major sector. Let's note the arc length of the major sector by an r, right? So perimeter will be r plus capital R. So r is 3 plus 3, and this is r into r times theta. 3 and theta of this sector will be 2 pi subtracted from theta, right? Because 2 pi is one complete revolution, and this theta is part of that revolution. So the other part will be 2 pi subtracted from the theta. We'll get 2 pi subtracted from 1.025 radians, right? Because we're working in radians. So the answer is 21.77 squared. Not squared, just centimeters, okay? Because square term is used for area. Because in area the lengths are multiplied, here the actual lengths they are only added, right? So the units they remain a single. For area, we'll have 1 by 2 r square theta. R is 3 again, but theta is 2 pi negative for subtracted from 1.025. Our answer is 97.965 centimeters squared. So this topic is relatively easy in A levels. You only need to learn these two formulas, this arc length and segment area, right? And the arc length and segment area, if you wish to work in degrees, you can use these two formulas, or if you wish to work in radians, you can use these two formulas.